Nishant Kumar Kant and I am a second year undergrad student from National Institute of Technology, Agartala. Welcome back to my channel where we will be solving another super interesting question from JEE Advanced. So let's get started.
So in this question we have been given that we have a parallel plate capacitor with two square plates. The sides of each of the square plate is A and the plates are separated by a distance D, and the lower half of the parallel plate capacitor is filled with a dielectric with a dielectric constant K. So we need to find out the total capacitance of the system. So let us consider this is our total capacitor. Let us consider this vertical distance y, then this small distance will be d minus y. Again, let us consider this distance as x and the thickness of this strip as dx. Now, the capacitance of this part, let it be C1, and the capacitance of this part, let it be C2. Now, the small capacitance of this strip, that is dC1, can be given as dA into epsilon naught divided by d minus y. That means small a into epsilon naught into dx divided by d minus y. Why this? Because dA can be given as a into dx, that is the small area out here. So this is the value of dC1. Let us consider this as equation number 1. Similarly, dC2 can be given as dA into epsilon naught divided by y, which will be equal to a into dx into epsilon naught divided by y. This is equation number 2. Now, the total capacitance of this complete strip will be the series combination of DC1 and DC2. So DC total, small total capacitance will be equal to DC1 into DC2 divided by DC1 plus DC2. So DC total will be equal to A epsilon naught dx upon d minus y into k into A epsilon naught dx upon y. Here it will be k into dA epsilon naught because that part is filled with a dielectric of dielectric constant k, divided by A epsilon naught dx upon d minus y into k a epsilon naught, sorry, it will be plus k a epsilon naught dx upon y, which will be equal to k a epsilon naught dx divided by y plus k into d minus y. This will be dc total. Now integrating this, dc total will be equal to ka epsilon naught integral dx divided by y plus k into d minus y. Let us keep this equation aside for a while. Now let us see, here in this parallel plate capacitor, this distance is d and the length of each side of the parallel plate capacitor is a. So if we consider this total triangle and this small triangle, this small triangle and this total triangle, then by the similarity of triangles principle, we can say that the ratio of the sides d by a will be equal to y by x by the property of similarity of triangles. So y will be equal to d by a into x. Now we will be putting this value of y in this particular equation and calculating the integral. So integration of dc total will be equal to ka epsilon naught integral dx upon d by a into x plus k into d minus d by a into x. X will be varying from here. X is varying from 0 to a. So x will be changing from 0 to x will be changing from 0 to a, and the total capacitance will be changing from 0 to C total. So C total will be equal to K A square epsilon naught integral dx upon xd plus k a d minus k x d, which will be equal to k a square epsilon naught into integration of dx upon xd into 1 minus k plus k a d. So let us consider t equal to xd into 1 minus k plus ka d. So dt will be equal to d into 1 minus k times of dx. So ct will be equal to k a square epsilon naught upon d into 1 minus k integral dt upon t. Now here x was varying from 0 to a, 0 to 0 to a. So as t is equal to xd into 1 minus k plus kad, so when x varies from 0 to a, t will be varying from kad to ad. So when we solve this integration, we get Ka square epsilon naught divided by D into 1 minus K ln 1 by K. So if we take K on the numerator, so the negative sign will be coming outside. So the final answer will be K A square epsilon naught divided by D into K minus 1 into natural log of K. So the final answer, that is C total, is equal to K A square epsilon naught divided by D into K minus 1 into natural log of K. So this is the final expression for the total capacitance of the system. So I hope you understood the question and the solution of the question. So see you in the next lecture. Till then, bye bye, take care, and Jai Hind.